Okay, so Vanessa, what we will be doing today, we will be continuing our simultaneous equations. And I think we had some homework, and then we'll do some practice on simultaneous equations. And then I want to go back to showing you how to solve an equation, um, simultaneous equations graphically. So let me just share my
But
screen.
you know, I prefer to do
What?
elimination and not substitution.
I know you tell me that. Okay, let's
It's easier
yeah,
and it's
I think
faster.
I think so. I think it's easier and faster. Now the one we had last week, and I'm doing the corrected version of it because it really doesn't come out as fractions. It comes out as whole numbers. Now, the two
Yes.
methods, substitution, elimination, you choose the method you like best. And we will look later at graphing and another way of solving for simultaneous equations. So let's look at number 5 again. And I think Alva has said substitution. Let's do it substitution.
Mm-hmm.
And you see the screen, right, Vanessa?
Yes, Miss Barbara.
Okay, x plus 6y is 27, equation 1. 6x minus 2y equal minus 28 is equation 2. So using the substitution method, uh, we take the x plus 6y is 27 and change it to what x is. And that's subtracting 6y from both sides. That gives you x equal 27 minus 6y. And we substitute, that's why it's called substitution. We substitute this equation into equation 2 for 6x. So 6x becomes 6 times 27 minus 6y. Do our multiplication, combine the like terms. On the left side, we get minus 38y. And then we subtract 162 from both sides, and we get 190 on the right. So a minus 38y is equal to minus 190. Divide both sides by 38, we get y equal 5. Now, once we get the y value, we can take any one of our equations and solve for the x. So if we take the first equation, x plus 6y is 27. Substitute y, which is 5. So 6y becomes 6 times 5. X plus 6 times 5 is 30 is equal to 27. So we have x plus 30 is 27. Subtracting 30 from both sides, x minus 30 plus 27 minus 3. So x is a minus 3 and y is equal to 5. That's the substitution method. Now, the elimination method, then for the elimination method, you want to eliminate one of the unknowns, because remember, these simultaneous equations have two unknowns. So we want to eliminate one of them. So when you look at x plus 6y is 27. 6x minus 2y is minus 28. Okay, now we can multiply the first equation by 6, and it will be a 6x, and then we can eliminate the x's by subtracting. So multiply the whole equation by 6. 6 times x plus 6y equal 27. So when we multiply that out, what do we get? 6 times x is 6x. 6 times 6 is 36. 6 times 6y is 36y. 6 times 27 is 162. Now we can, we have, uh, now we subtract. So when we subtract 6x from 6x, we get 0. 36 minus a 2y. Minus minus give you plus, so that give you 38y. 27 minus 162, 162 minus 28 is 162 plus 28 give you 190. So 38y equals 190. Divide both sides by 38 and you get 5. Now we can substitute that 5 into that equation, the first equation, x, you could do it on either one. X plus 6y is 27. Put in the 5, plug the 5 for the y. That's 6 times 5. So 6 times 5 is 30. X plus 30 is 27. And that's just repeated. Just take this one out. We don't really need it, but one time, okay. X plus 30 is 27. And then we subtract the 30 from both sides. Okay. And once we subtract the 30 from both sides, let me just put this down, we get 27 minus 30 is a minus 3. So we got x is minus 3, y is 5. And that was by the elimination, the same value we got when we used the substitution. Any questions on that, Vanessa? Any questions, Vanessa, on that problem? You're on mute.
No, Miss Barbara, that's good.
Okay, all right. So that's the one we had before. It looked like we were getting two different values, but we're not. So we corrected it. And I sent it to you when I emailed it, but I just wanted to go over it. Now, Vanessa, did you do this first problem, the homework? Read that.
I didn't do any homework, Miss Barbara.
Okay, well, read number 3. Let's do it together. Read number 3.
Okay. The sum of two numbers is 209. If one number is 7 less than 2 times of the other, then find the two numbers or set up the two simultaneous equations.
Okay, now let's just, well, first thing we're going to define some variables here. So we say let x equal one of the numbers. You can use any variable you want, but we'll just use x and y. Let y equal to the second number. Now, if x is one of the numbers and y is the second number, that's the two numbers. How do we write, Vanessa, how do we write the sum of these two numbers equal 209?
Okay, the sum.
Sum means
Find the
what?
sum. To find the sum, it means to add.
That's right. So how would I write the sum of x and y is 209?
X plus y equal to 9.
That's it. Very good. See, x plus y equal 209. That takes care of one of our simultaneous equations. All right. The sum of the two numbers is 209. That's what we just wrote. Okay, sum means add. That means add the two numbers, you get 209. Okay, now, if one number is 7 less than 2 times of the other. Now, 7 less means what operation, Vanessa?
Less. Less than the minus.
Addition, subtraction, multiplication, division.
Subtraction.
Subtraction, that's right. 2 times of the other, that means what?
2 times means to multiply.
That's right. So one number is 7 less, so 7 subtracted from 2 times the other. So if we say 2x, 2 times one number, less than 7, well, one number is 7 less, that means we're subtracting 7.
Subtracting,
that's
yes.
right. So 2 times the number,
subtract
7 less than 2 times of the other. So x plus y is 2 over 9,
Mhm.
209.
So therefore you minus, you subtract y. Should it special?
We have 2x less than 2 times the other number.
Less than, okay, 2x minus 7y.
Well, we're saying one number is 7 less than 2 times the other. So if that number is x, we'll say x equal. So one number we call x, and it's 7 less than 2 times the other. What do I write after the equal?
2.
Okay, 2 what?
2x, right?
No, x is the number I'm looking for. So,
okay.
So if that number is 7 less than 2 times of the other is going to be the 2y, right?
Oh, you mean the 2y.
Yeah, so 2 the other, so it can't be x. So one number, and we call it that x, is 7 less than 2 times the other. The other number would be the y. So what do I write after that, Vanessa? I want to write 7 less. How do I write 7 less?
Minus.
Yes, minus
7.
That's it. Yeah. One number, we're calling that x, is 7 less, that's the minus 7, 2 times the other, and the other is y. Okay. So we say one of the numbers is x and one of the numbers is y. So one number, x, is 2 times the other, which is y, and then 7 less than that, which is 7 subtracted. All right. Those are your two simultaneous equations. Okay. Now, Vanessa, if you wanted to solve this, what would you do? Hello, Maureen. Yeah, if you wanted to solve this for x and for y, what would you do?
Therefore, I'm not sure.
Now, see, this is one that actually the substitution method is better. Remember I told you sometime one is better than the other. And the reason the substitution is better because you see what x is. X is 2y minus 7. We can substitute x into this equation. Okay, let's just call this 1. All right. And let's call this 2. Now, we could substitute 2 for x in the first equation. So do that, Vanessa, and then solve it. All right, substitute 2 in 1 for x. Okay. So do that, Vanessa. Substitute 2 in 1 for x. So what you're going to do is take this equation. Let's just copy it. And we're going to take, since x is 2y minus 7, let's just put 2y minus 7 here. 2y minus 7. All right. 2y minus 7. Now what do we do?
Said you substitute 2 in
Let's-
1 x, right?
Okay, so solve this equation. What would you do first?
Like signs together.
So I combine the like terms. So what terms can I combine here?
Like 7, 2, and 9.
Well, you could add 7 to both sides. Okay, we could do that first. Add 7 to both sides. All right. And if we do that, let's do that. Let's take this, add 7. Add 7 on the left. And then add 7 over here. Okay, now what do I get left on the left side? What's remaining? There's a minus 7 and a plus 7. Maureen, you're on mute.
0.
0. And so what I have left then what? 2y plus y. Plus y, because minus 7 plus 7 give you 0. So here we go. Okay, so 2y plus 1y is what, Vanessa?
2.
Add the coefficients, 2y plus 1y.
3y.
That's it, 3y. So this would be 3y. All right, take out the 1y because we added it. And what's 209 plus 7?
216.
216, okay. Now, so y would be equal to 216.
Divided.
Right, equal 216 divided by what? 3. Okay, what's that equal to? 3 into 21 goes what? 21 divided by 3.
That's right. 72.
Is 7, right? And that's right, 72. So what is x equal to? How would we solve for x?
Take one of those.
One of the equations, 1 or 2, and substitute for y. So let's just take the first equation. All right. And substitute for y, 72. So this one, y is 72. So we put 72 here. So what is x? Subtract 72 from both sides. So x would be 209 minus 72. And what is that equal to? 2 from 9 is 7. 7 from 10 is 3, right?
137.
137. And 137 plus 209 would give you 137 plus 72 would give you 209. Now, what about this one? What's 2 times y? 2 times y is what?
2 times y?
Yes.
Times
144 And 144 minus 7 is 137. So we can see this is correct. So our answers would be X equal, what was our X equal to? 72. No, Y was 72 and X equal 137 and Y equals 72. That would be the answers to these two simultaneous equations. Now, notice I said this one was easier to do by substitution because you have this one in the format of what X is equal to. So you can just substitute that in for X and you just have Y left. And when you solve for Y and get its value, then you can use that to solve for X. Now you could have used elimination here, right? Because you could have put the X minus 2Y is minus 7 and then just subtract it. And try that, Vanessa. See if that's easier. Take these two equations. Okay, let's just take these two. That was the substitution method. Use your.
What are we using now? Elimination?
Yes, use the elimination. Okay, this one, I want you to use elimination method. And what I said here, you could subtract the 2Y from both sides. That's for number 2. Let's just say subtract 2Y from both sides in equation 2. All right. Now, if we do that, let's just write X, I'm writing equation 1, X. Let me just copy it. So this is X. And then subtract 2Y from both sides. This becomes what? Let me copy this one. Subtract 2Y from both sides. I'm just trying to get it in the same format as this one. Then this becomes both sides of number 2. So that would be X minus 2Y equal minus 7. Okay, now, since we see X and X, what can we do with these equations? They just have Y left. Vanessa, what could we do?
Since we have Y left.
Yeah, if I subtract, okay, subtract this equation from this one, X minus X. In other words, subtract this equation from this one. Let me just label these. And then I'll just call them by number. Okay, this is 1, this is 2. And what I'm saying is subtract equation 2 from equation 1. So I'll just say that, subtract equation 2 from equation 1. What do you get, Vanessa?
Equation 2 from equation 1.
Yeah, let me just put on the line. What do I get when I subtract equation 2 from equation 1? X minus X give you what?
X minus X gives you minus 2X.
No, X minus X.
Oh, X minus X gives you 0.
That's right, gives you 0. Okay, now Y minus a minus 2Y.
Y what?
y
Y.
minus a minus 2y. Minus minus is a plus, right? So that's going to give you a plus 3y. Y minus a minus. The minus 2y becomes a plus 3y. What's 209 minus 7? Minus a minus 7. What's that equal?
202.
No, that's 209 minus a minus 7. Remember, we're
Oh, you have
subtracting.
to add it. Okay. It's a
That's right. You got
plus
it.
216.
That's it. And is that the same thing we got over here?
Yep.
3y is 216. So 3y equal 216, and y is 216 over 3. 216 divided by 3, and that's equal to the same thing we got over on the substitution side, 72. Okay. And then we can just substitute the 72 just like we did before. Substitute the 72 in one of the equations. Okay, and we'll just take it here. All right. So we can substitute x plus y is 209, x is 209 minus 72 is 137, and we get the same answers. X equal 137 and y equals 72. See, this one you can do elimination, but what you want to do, Vanessa, is get them in the same format. Then you could just subtract them. X minus X, that would eliminate the X, and you only have Y left. So which one you think is easier, Vanessa? Still elimination?
Elimination.
Okay. Yeah. But get them in the same format so you can subtract them, or in some cases add them and eliminate one of the variables. And you can solve for that variable and then use that value to solve for the next one. Maureen.
Yeah.
Oh, I didn't hear you before. Okay. Did you do your homework, number 3?
I had get out that number, but I didn't do it like that.
But did you get X 137 and
Yeah.
Y 72?
Yeah.
How did you do yours?
I had my writing on a piece of paper. I can't remember what I did it, but that was not saying get out.
How did you do it?
I can't remember how I did this time. I know I put like let X be like, okay. You see like how you got here, let X be like a 1 and 2?
Yeah.
And that's all I did, but then I figured out. Yeah.
Then what did you do from here?
I can't remember. I just figured out. Yeah.
You just figured it out, but what did you do? You had to have a process.
Yeah.
What was your process?
I really didn't do it that day. Like I write like how I figured out like cause I had used one exactly third, fourth, or right like the first one like A for adults and C for kids, and A plus C equals the $1,000. So I figured out from this one, I had only do 4 first. But I didn't write nothing for 3.
Oh, you didn't write down your process for 3.
No.
But you
I
got.
figured out I do number 4.
Okay, well, let's go to number 4 then.
I really couldn't understand that there, but then I figured out number 4.
Okay, all right. Give me your solution for number 4. What did you do?
Okay, let's see. Wait first. Okay, I write first. Okay.
What were your variables?
This is how I write my if. Let's see. I would let if be the number for adults.
Okay, let A equal adult tickets, right?
And C equals children.
Okay, let A equal, and that's the number of
Right, ticket.
adult tickets. And then you use what for children?
C.
Okay, so let's see. So C was the children tickets. And then what was one of your equations?
Then I write A plus C equals to 1,000 tickets, right?
Okay,
That's how I do mine.
okay, that's right. 1,000 tickets were sold. So you had A plus C equal 1,000. Okay, so far you're doing great. And what did you have? What was
And
your
then
next?
I put, my next step was 850 plus 450 equals to 73.
No.
Well, that's as well.
Well, the total of 7,300 came from the number of adult tickets sold at 850 plus the number of children's tickets sold at 450. So what was your next equation?
There's right after that one. They write 850 plus 450 equals to the 73. To the 73 total, to the total
You had 850
450
plus 450.
equals to the $73, 7,300. I don't know if I do it right.
Well, but that's not equal to 7,300. Vanessa, what's the 7,300 equal to? Vanessa?
7,300, it's equal to what, 1,000?
No,
No, it cannot.
it's the
That the
number.
amount, that the total amount of, the total amount that you collect for the tickets, right? You know.
Yeah, but it's the number of children's tickets
73 was collected.
time its price plus the number of adult tickets time its price, right? So if your number of adult tickets was A, this will be 850 multiplied by A, right? And the
Okay.
450 multiplied by C. In other words, it's the number of tickets sold times the price of one ticket.
Uh-huh.
So 850 plus 450 does not equal 7,300, but 850 multiplied by the number of adult tickets plus 450 multiplied by the number of children's tickets is equal to 7,300.
Okay.
So those are your two equations.
Uh-huh.
Now, solve for the number of adult tickets sold and number of children's tickets sold. How would you do that?
Then my next step was C, which is children, equals to 1,000 minus adults.
Okay, so you took this equation. Okay, let's take number one. We'll call that equation number one of our simultaneous equations. And this one is number two. Okay, so you took the first equation and changed it to A equals, okay. Change equation number one to, and you say C equal 1,000 minus A, right? To C equal 1,000 minus A. So you're using the substitution method. Then what did you do next?
Okay. Let's see.
So C,
Okay.
What was your next step, Maureen?
My next step, I put 850. I ain't sure if it right. Plus 450. And then I put the 1,000 minus the 8 adults in parentheses. I don't know if I did it right.
What did you put?
I put 850 plus 450. And then I put 1,000 minus A in parentheses, and they put equals to 7,300. But I don't know if I went right there.
No, what you have to do is substitute this into this equation. So you want to substitute C equal 1,000 minus A in equation 2. Okay. For C. So since C is 1,000 minus A, you can put where you see C, put 1,000 minus A, then you'll only have A. So that's what you have to do, Maureen, because you're
Okay,
trying to eliminate one of your variables. So let's just take this equation. Okay. And substitute what you gave me, that 1,000 minus A, right? So for C, you want to put right here 1,000 minus A. Now, what is that equal to?
Oh, then let me see. Okay. Where they put
So when you do your multiplication, what do you get?
850.
Okay. What's up? 4.50 times 1,000 gives you what? What's 4.50 times 1,000?
45.
4,500, right?
Yeah.
So this would then be 4,500. Okay. And what's 4.50 times a minus A?
450.
4.50 times a minus A. That would be a minus
450.
4.50 A, right?
Yeah.
Okay. This is decimal point.
Okay, let's see. They got 858.
Okay, then what did you do? You want to combine your like terms, Maureen. How do you combine your like terms?
Okay.
What are your like terms here? 8.50A and 4.50A, and constants 4,500, 4,500 and 7,300.
Well, then I put, I don't know if I write it right. Then I write 4A. I'm not sure. Equals to 73,000 minus 45,000 equals to 2,800. I don't know if I did it right, but that's how I do it. I'm telling you.
What's 8.50A minus 4.50A? When you subtract 4.50 from 8.50, what do you get? Maureen?
400.
You get 4.0. not 400,
Yes.
because okay, so that's 4.00A, right?
Oh,
So
well,
4
but I
point,
still paying. I didn't put the 2 zeros, but I just put 4.
yeah,
I
you could just put 4. Okay, so we'll just put
yeah.
4A. All right. You don't have to put the zeros. Okay, so that's 4A, and that's plus our 4,500. Okay, and we're just repeating the constant that's there, plus 4,500 equal 7,300. What's your next step, Maureen?
Yeah.
How did you combine the constants, the 4,500 and the 7,300?
I subtract.
That's right. Subtract 4,500 from both sides. Okay, so if we do that, let's see, let's just do that subtraction. Okay, 4,500 subtracted on the left. 4,500 subtracted on the right. And what do we get on the left side, Maureen? What's
7,800.
on the left side?
Oh,
What's 4A plus 4,500 minus 4,500?
4A man. 4A minus.
What's a plus 4,500 and a minus 4,500?
Let's see.
Plus a minus of the same value
Uh-huh.
gives you 0, whether it's
Okay.
constants of
Yeah.
variables. So,
45 from 45 is 0.
that's it. So you have 4A equals, what's 7,300 minus 4,500?
28.
28,
Uh-huh.
2800. Now what's A equal to?
4. So you
A,
divide by 4, right?
yeah, divide by 4. So that's 2,800 divided by 4. And what's that equal to?
700.
700, 700. So the
So
adult
that's
ticket,
700. Right. Okay.
that's the number.
That's
So how many children's tickets were sold?
300.
That's right, because A plus C, you take this equation, A plus C is 1,000. So that means if you put the 700 here, C is 1,000 minus 700. How could you check it, Maureen?
Okay. I got a clue this time.
Minus 700 equal 300. Okay, so tickets sold.
Ticket so was $700 for the ticket.
Was 700 adult,
Adults and 300 children.
right? 700 adult and 300 children. How could you check it, Maureen? How could you check that this is correct?
I didn't know this Bible.
Well, you know you sold what? $7,300 worth of tickets. So this 700 times 850 plus 300 times 450 must equal to 7,300. So check that. See if 700 times 850 plus 300, and the children's tickets was 450. What is that equal to, Maureen? That must equal to 7,300 for this to be correct. So what's 700 times 850?
That's a big multiplication.
700 times 850, I get 5950. All right. And then 300 times 450 is 1350.
Yeah.
Okay. So 5950 plus 1350. And what's that equal to? 7,300.
Three. Yeah.
Right. So we know it's correct because that was the total. So that's how you can check it. The number of adult tickets times the price of one adult ticket plus the number of children tickets times the price of the children's ticket. So you add those up, you should get the total that they made, that they collected, 7,300. So we know it's correct.
At least I get one right.
All right. Very good. Okay. Now the homework that I gave you homework, well, actually a week ago, but we want to look at it. That second one was incorrect because I didn't give you variables in both, the same number of variables in both equations. So I changed it to this one. So I want you to, first of all, do number one. Let me go here. Okay, so do number one. And number one, notice you have the same variable and coefficient in both equations, right?
Mhm.
So what does that mean, Vanessa, when you have the same, you have 4y here and 4y here. So what can you do to these equations to eliminate? This is a good one for your elimination. What can you do to eliminate the y, Vanessa? What operation?
To eliminate the y.
Yes. This is a good one for elimination because, well, right
Because-
here, you've got the
Yeah, because
same.
you add 6x.
Well, that's right. You could just add these equations, right?
Just add them and pair
Yeah, and
four
you're right.
y's, you just eliminate it.
That's it. 4y plus 4y. So you're adding.
Yes.
Add equations.
2x.
You don't have to do anything to them, just add them because there you got something in common for these two equations. So you're right, Vanessa, you get 6x here. And
Yeah.
this plus 4y minus 4y is 0. So that would just be 6x. And what's 14 plus 4?
18.
So you know the answer then. What's the answer?
3.
3. That's right. 18 divided by 6.
Totally, elimination method is better.
Yeah, that would, especially this one, x equal, and you look for things like that to make your work easier, where it's already, you don't have to do anything to just add the equation. So x equal 18 divided by 6 equal
3.
So what is
Here
y
you
equal
find,
to?
so where everywhere you see y, you take one of those same equations, and where you find y, you plug in 3.
You mean where you find x?
X. Where you find x, you plug in 3.
That's right.
So we
if,
can use 4x minus 4y equal 4.
Okay, you want to use this one? Let's take this one then. Okay, let's take that equation and plug in
Okay,
our.
before you go any further, how you get this 6, 7? You make say 4x minus 4y equals to
How did I
4.
get one?
How did you get the 6x equals to 18?
Okay, I added these two equations, Maureen. 2x
Uh,
plus 4x, the coefficients,
uh-huh,
2 plus 4, and I got the
uh-huh,
6x, right? And
uh-huh,
4y, the plus 4y and minus 4y is 0.
uh-huh,
Remember when you add
uh-huh,
when you add two entities, whether they are constants or whether they are variables or constant variable combinations, if they're the
uh-huh,
same value, one is plus minus, you get 0. And then
uh-huh.
14 plus 4 is 18.
I see. Okay.
So you added these equations and eliminated the y because the plus 4y and minus 4y gave you 0. Got it?
Uh-huh.
So adding these two equations, you get 6x equal 18. Then divide both sides by 6. 18 over 6 gives you
Uh-huh.
3.
Okay.
Now, Vanessa said she wanted to use this equation and you substitute.
Let me do that. And 4 3s is 12.
Substitute 3 for x. And then you can solve for y. So what does this become? Let's just substitute
They
this.
said 4x minus 4y equal 4. So
Right.
where's x, you add 3, you
You
put
put the
3. So
3.
this becomes
That's right.
multiplication.
That's right. That's
So you said 4 3s are 12 minus 4y
so that's 12
equal.
minus 4y equal 4.
Okay, fine. So what you do, you bring over which one? Okay. I would prefer to bring the 4 over, change the sign so this becomes minus 4x.
I'll be right here now. 12 minus 4y equal to 4. We want to solve for y. What do we do first, Vanessa?
So you subtract 4 on both sides because I bring over the 4. Or you prefer to do the 12? Take the 12 over.
Yeah, I think the 12 would be better. Subtract the 12. Okay, subtract.
You wouldn't get the same answer, Miss Barbara.
You get the same answer. Subtract 12 from both sides.
This becomes 0 here, minus 4y.
Okay, so you subtract 12 and what do you get is minus 4y minus 4y equal 4 minus 12. And what does that give you? What's 4 minus 12?
Oh, so you get a minus 8.
That's right, minus 8. So this will be minus 4y equal minus
So therefore it's
8.
2.
That's right. So y
So
then would be equal to, because minus over minus
2.
is plus. So y
2.
equal minus 8 divided by minus 4, which just gives you 2. So y is 2 and x is 3.
3.
That's right. That would be your answer.
Shorter. That's far shorter to me.
Okay. So our answers would be x equal 3 and
Y
y equals 2. Questions, Maureen?
No.
Okay. All right. So you solved that one. Let's now the next one, like the one I gave you, actually, like it was an error because I didn't have both a and b in both equations. So I changed it. So this is the new equation. I want you to solve this for a and b. Solve for a and b. Use any method you like. Now, this is a great one for Vanessa's
That's
elimination.
3. That's
Right.
number 2.
Now, this is,
Okay. Okay.
yeah, this is number 2. Because I changed number 2. It wasn't the 2 that was on the original one because I had A and B, but the second equation did not have both A and B. Now, this one, elimination method would be the best because what? You can make
It's 2.
you can make these 6A, right? And then you can subtract out the A.
2.
Let me copy this.
You can make what, 6A?
Yeah, you can make both equations.
Oh,
In other words, if you want to eliminate the A, you can multiply the equation. Well, let's see, I'll call this 1. All right, this is number 1. This is number 2. You can multiply equation 1 by 3 and multiply equation 2 by 2. And then you could eliminate the 6A. Follow? Maureen?
No, Miss Barbara.
Okay. Now, elimination would be the best way to do this one. But since you have a 2 and a 3, they both have least common multiple of 6. So 3 times 2 is 6. 2 times 3 is 6. So you're going to multiply, because if you get 6A for the first one, 6A for the second one, then you can subtract them, right? So multiply equation 1, the entire equation, by 3. Multiply equation 2 by what? What would I multiply equation 2 by? I'm trying to get 6.
2 by 3.
No, I'm trying to get 6A. What would I have to multiply this equation 2 by to get 6A?
3A.
Well, what do I multiply this equation by, the whole equation by, to get 6A? Number 2.
Oh,
What number multiplied by 3A gives 6A?
2A.
2. It'd be 2, not 2A, just
Yeah.
2.
2.
By 2.
That's 2.
By 2, right? Because then you could eliminate 6A. So let me just copy these equations and put the numbers that we're multiplying in front of it, and you multiply them out, okay?
Yeah.
Okay, let's just put it here. Now put a 3 here.
Okay.
The whole thing in parentheses because you multiply the right and the left side, okay? And then this one, put a 2.
Okay, 3.
So
Yeah.
do that, and
Three,
now you can
2.
subtract out the 6A. So Maureen, what do you get for the equation 1 when you multiply? What do you get? 3 times 2A is what?
6A.
That's it, 6A. What's 3 times 6B?
18.
18B.
Mm-hmm.
And what's 3 times 20?
3 times 20 is 60.
60. All right. Now let's go to the next one. Equation 2. What's 2 times 3A?
2.
2 times 3A is what?
6A.
That's it. Very good. 6A. Okay. 2 times 4B is what?
8B.
8B. Right. 2 times 10
20.
is 20. 2 times 10 is 20. Okay, now you have these two equations, right? But you see you have a 6a there. So you can subtract them and eliminate the a. Okay, so let's just draw a line here. Now subtract, and I call this one
That's
and this 2, and I want you to subtract equation 2 from equation 1. This is 2. Subtract equation 2 from equation 1, and what do you get? Move this over so it's lined up.
40.
What's 6a minus 6a?
6a minus 6a is 0.
That's right. So let me just put here, subtract equation 2 from equation 1. All right. So 6a minus 6a is 0. Maureen, what's 18b minus 8b?
10b.
10b. Very good.
Yeah.
Okay, so that would be 10b. And what's 60 minus 40? I'm sorry, 60 minus 20.
40.
60 minus 20 is 40. Okay, so if 10b is 40, what is b, Maureen? How do you find it?
Okay.
What do you-
So, Miss Barbara,
yes.
excuse me,
Okay.
with this, whether substitution or elimination, when you already able to multiply the two equations, you able to eliminate 6a.
That's right. I can eliminate the a, and I'm gonna only have b as the variable that I'm looking for.
Fine. So when you get b, you have to subtract.
Well, b is equal to what? What is b equal to right here?
Where?
10b is 40, so mental
4.
math, b is equal to 4, right? Because
4.
b
Yeah.
is 40
No,
over,
because that is how, because since you have plus signs in front of the 18b and plus signs in front of 8b, I thought you had to add them.
when you have one.
You have, when we finish doing the distributive properties
We
on both,
start,
and then,
oh, you mean right here?
yes, and then you eliminate the 2 6a from the two equations.
Right.
What do you leave with? Isn't it a positive 18b and a positive 8b?
No, see, I subtracted, okay, so when I multiplied this out, I got what? 18b and I got 8b. Then I subtracted equation 2 from equation 1. So 6a minus 6a gave me 0. 18b minus 8b gave me 10b. And 60 minus 20 is 40. I'm subtracting.
Oh, you have to subtract it.
Subtract. That's right.
Okay. Okay.
Yeah, you subtract.
Okay.
Okay. That's because that's
And
the only way you're
and
going to
then
get,
divide.
because if you add it, you're going to get 6a plus 6a is 12a, and you still have a and b, right? So
Okay.
you subtract so you can eliminate the a, because 6a minus 6a is 0.
Okay.
See, this is a 0
Understand.
here. I'll put it here, 0
Understand.
plus, okay. So that's a 0, right?
Therefore, b is
That's a 0.
So
I have left 10b is 40, and b is 40 divided by 10, which is equal to 4. So what is a equal to?
so where everywhere you see a, you put
Well, I can take either equation here and plug in my b.
You plug in
Four-
your B.
4 times 4 is 16, right? And 3a plus 16 is 10. Okay, so 16, 10 minus 16 is what? 6 minus 6. 3a is minus 6. A equals minus 2. So you could take the b and plug it into either one of these equations and solve for
Mhm.
a,
Mhm.
right? Substitute b equal 4 in either equation
This is right. This is
and solve for a. So do that. Substitute b and equal 4 in either one of these equations and solve for a. Tell me what you get for a.
negative 8.
Maureen, are you doing that?
So you do B. Okay. And I get
Because substitute it
12.
in either equation, that first one or the second one, you can
12
substitute
and
it in, okay?
6. This becomes.
Which one are you
Yes.
using, Vanessa? 1 or 2?
I use 1.
Okay, so you're using 2a plus 6b is 20.
So therefore, B is 4. Right? And A is 2.
So you're using 2a plus 6b is 20. This is the one you're using right here. Is that the equation you're using, Vanessa? 2a plus 6b is 20. Is that the equation you're using?
Huh?
Are you using the 2a plus 6b equal 20?
Yes, Miss Barbara.
Okay, so let's just take that equation and put our b is 4.
Mhm.
Okay, put it here. Now b we said is 4, right?
Yes.
So we take our b and put 4. So let's just copy this and substitute for b the number 4 that we calculated. So let's put our
Probably
4
2.
here. What did you get, Maureen? Did you calculate it?
Well, if you take out the, it is,
What did you get? What did you get for a?
I know, I get 2, but I know. I said
Got
6.
2. Okay, so this is a 24. 6 times 4 is 24, right? Now subtract 24 from both sides.
Okay. 2 is
24 from both sides. Okay,
6.
and that would be, let's put 2a plus 24 is 20 and subtract out our 24.
2
On
is
the left side minus 24 and on the right side minus 24. So what do we get on the left side, Maureen?
2 plus
2a plus 24 minus 24. What do you get? You just get 2a, right? Because plus 24 and minus 24 is 0. So 2a, and what's 20 minus 24, Maureen?
4.
Plus or minus?
A minus.
Minus. That's a minus 4, right? Now, a then will be equal to what? A would be equal to minus 4 divided by 2. And what's that equal to, Maureen?
2.
Plus or minus?
A minus.
Minus. That's right. You were saying 2. That's 2. When you say 2 without a sign, you're saying a +2. So it's a -2. All right. So we have what? A equal -2 and B equals what? 4.
Yeah.
That's the solution to those simultaneous equations. Bigger. Questions on that?
Okay.
Got it? Question, Vanessa?
Barbara.
Okay. So that's one where you use elimination, but you did the elimination by getting rid of one of the variables by multiplying both equations by numbers. So you could subtract out one of the variables. See, sometimes you can just multiply one equation by a number, but this one you had to do both equations by a number. So you get the 6, and then you could eliminate the 6. In that case, it was a 6A. Okay, now I have a word problem I want you to do. Let's see if I can bring that down. Okay. Okay. Now let's okay, here it is. Okay, I want you to solve this equation. Right? Let me break it down so you can see the whole thing. Can you see that, Mahesh?
Let me see. That was, whoa.
Let's see. Let me bring it. Okay. Read that equation. Tell me the 2 simultaneous equations you can write.
Can you break it down a little further, Miss Barbara?
Okay. Let me bring it down.
Good, good. You're going too far.
No, I'll bring it up.
Okay.
Okay. Now
All
can
right.
you see it right here?
Yeah.
Okay.
Concentrate.
Okay. Now you got bushes and trees. So put variables to represent bushes and trees. And then tell me
Yeah.
there's 2 simultaneous equations.
B for bushes and T for trees.
Anybody got an answer?
Okay.
Any answers? Number 1?
There.
got bushes and trees. So first thing you're gonna let something equal, some variable equal bushes and some variable equal trees. You don't have to use B and T. You can use X and Y if you like. I just say B is bushes and T is trees. So,
First one, can you put
so what would you have, Vanessa? Tell me what you would write.
87? So you can use 13B
Okay.
plus 4T equal 487.
Okay. 4, 8, 7. Okay. Very good. That's one of your simultaneous equations. What's the second one?
The second one is 6B
Okay. Okay. 6 bushes.
plus 2, no, yeah, 2T
Mhm.
equal 232.
232. Very good. Is that what you have, Maureen?
Yeah.
Yep. That's it. That's the answer. Okay. Now, let's go to the next one right here.
A perimeter of a rectangle.
Can you see that one? Make it look bigger. Okay. Perimeter of the rectangle, 158 centimeters. Length is 7 more than 3 times the width. Write 2 simultaneous equations that can be used to calculate the area. And you know area is what? Length times width.
Yeah.
And you know the perimeter of a rectangle formula is what, Maureen?
2 width, 2 length.
2 length plus 2 width.
Width.
Okay. So I want you to give me those equations. Bring it down here.
Oh, you said it's 2 length, 2 length,
Give me the 2 simultaneous equations. Okay.
2 less.
Let's bring it over here. Okay, here we go. Okay.
If the length is 7 more than 3 times the width. Okay.
2 equations that we could use to calculate the area, which means to calculate the area, we want to what? Find the length and the width. The equations to be used to find the length and the width.
Okay. Trees. Then 2 of 12. The perimeter of a rectangle is 158 centimeters. Okay. Perimeter is
Okay, if you want to use L equal length and W equal width. So So what would the perimeter, if L is length and W is the width, what would be the perimeter formula? That would be one of your simultaneous equations. What would that be?
Okay.
What's the formula for perimeter?
Parameter is 2 length plus 2 width.
Right.
That's right. Let me just write that here. Perimeter equal 2L plus 2W. Now, what's the perimeter in this formula?
158 centimeters.
That's right, 158 centimeters. So we put in our 158, that's our perimeter. That's equal to 2L plus 2W. Now, how do we write the length is 7 more than 3 times the width, Vanessa? Length is length equal 7 more than is what? Add 3
The width.
times is multiplication. So Vanessa, how do I write length is 7 more than 3 times the width? How do I write this?
Length is what? I think
Is equal. So how would I write that?
If the length is 7 more than 3 times.
More than is added, 3 times is multiplication. So Vanessa, how do I write length is 7 more than 3 times the width? That's your second simultaneous equation. Length is means length equal 7 more than means to add 7.
So you got to add 7 to the
width is multiply. Maureen, you know?
you got to
lost.
multiply. You got to multiply by some number. It's 7. You got to put 7. So I will put 7L.
No. Vanessa, how do I write length is?
Length equal.
Yeah, L equal, right? L equal. Length is, that's length is L equal. Now, what is it equal to?
7.
7 more than 3 times the width. So how do I write 3 times the width?
Three times could was 3x.
Now I'm using L and W.
Okay.
Length is 7
3.
more than 3 times the width. So I'd have 3 what?
3W.
That's it. Very good. 3W. Now 7 more than.
Add, right?
That's
Plus.
right. Add. So that would be plus what?
Plus
7.
Plus 7. That's it. Those are your 2 equations. This is number 1. This is number 2. This is number 2. Remember, tasks deal a lot with setup. So you want to be able to look at word problems and create the mathematical expression for that. So perimeter 2L plus 2W, you know that definition. They
Yeah.
gave you 158 as the parameter. That's 2 times the length plus 2 times the width.
The best.
Then the length is L equal 7 more than means to add the 7. 3 times the width that you're adding it to is 3W. Any questions on number 2?
It's simple thing you explain it, but to think of it.
Yeah, you gotta, well,
Yeah.
you gotta think of what these actual words mean. When it says is, that translate to a mathematical equal sign. More than translates to an addition sign. Times translates to a multiplication, which can be side by side. 3W means 3 times W. See, I could say 3 times W this way. I could say 3 dot W, 3 asterisk W. I could use parentheses, right? So different ways, or I could use the X. Try to stay away from the X because we use X as variable a lot. Any questions on number 2? Questions?
No.
All right, let's do number 3. Okay.
Miss Barbara, I think I have to run. I have to do something tomorrow.
Okay. All right. So, okay. So what we will do is.
So I could go too.
Yes,
If she don't want to go, yeah.
No, because I have to go. I have to.
Oh, that's not you. No problem.
Okay, but I want to give you. Let's see. Okay. So we'll stop here and I'll have
Yeah.
this for your homework, these word
Yeah.
problems. But there's
Okay.
something I want you to do today. Okay.
I would not, because I have to do something early tomorrow. So I have to go get these things. That's
Okay.
why. Trying to sit in to see how much I could.
Okay. But remember when I told you about you could solve the equations graphically. Let me just quickly show you this. Graphically, wherever there's an intersection, that's the value of your X and Y. So there's a 2 on the X and there's like it's a 3 on the Y. So that means they intersect at 2 on the X and 3 on the Y. Now, in a table, you can also show this. You have 2 equations. Wherever you see the same value for X and Y, that's the intersection. And notice here you have 2, 3, 2, 3. That's the only place they are equal. All right.
Where? I'm not seeing it.
Oh, wait. Okay. New share. Okay. Do you see it now?
Yes.
Okay. Yeah, there's the graph. Wherever 2 lines intersect for 2 equations, that's the value of X and Y. So the intersection is right here at 2 horizontal on the X and vertical 3 on the Y. You see that, right?
Yeah.
So if I gave you an intersection, you just read off the X and read off the Y. Now you can do the same for a table. I give you tables for these equations. All right. So wherever you see the same X and Y, that's the intersection. And that's only one place, 2 for the X and 3 for the Y. 2 for the X, 3 for the Y. All the other places, they are different. Got it?
Yeah.
Any questions on using the graphs or tables? For finding the X and Y values. Now, that being said, I have a, let's see, new share. Okay. I am going to send you this. It's only 3 problems.
Okay.
All right. Now, I want you to answer these and text me the answers.
Okay.
Okay. It's 3. Now, this one, I only gave you one line.
Uh-huh.
So you need to plot this second line, and that would give you the intersection. And to do that, you just put them in tables from 0 to 3 and find the y value and put it on this line, and wherever the intersection occurs, that would be the answer to the problem. Okay, now
Mm.
this one, you look at these tables, and
Uh-huh.
wherever you see the same X and Y in both tables, that would be the solution for this one. And this
Uh-huh.
one, of course, you can solve it by
Okay.
elimination or by substitution.
Okay.
Okay, so
So let me ask you, are you doing the rise over the run?
no,
Where
no,
is
we're not doing, we're
y1,
not,
y2
well,
over x1 over x2?
no, we're not doing the slope.
Okay.
Okay, now this one, I gave you one line, right? I want you to find that second line. And that means you've got to take this y equal 3 over 2x plus 2. Actually, what I think I'll do, when I send you this, I'll give you y. And then you could, for this one, and you can just plot it. And wherever that intersection occurs, that would be your answer.
Okay.
Okay, so on the first one, I will give you the values for the second
Yeah.
equation. You just put them on this grid, and wherever they intersect, that would be the answer for the question. Okay.
Okay.
Just like this table, these two tables, wherever you see the same value for X and Y, that would be the solution. Got it?
Okay.
And
Yeah.
then this one you can solve. Okay, so when I send you the session, I'll send you this one, and then I want you to text me the answer.
Those three answers. Okay.
Yeah, and all you need to do is say like just put the 1 and just say if it's A, B, C, or D. 2, whether it's A, B, C,
Okay.
or D, and 3. Any
Okay.
questions? Okay, so we're gonna end here. I'll send you the
Yes.
session.
Okay.
All right. And actually, I'll put it on YouTube because I have to text Alva to let her know everything will be on YouTube. Okay. So long.
Okay,
Thanks
Mr.
for joining.
Thank you
Thank
so
you
much.
too.
Okay.
All right.
Okay,
Okay. Have a great
Vanessa.
rest of the
You
day. Bye,
too.
Maureen. Thank you.
Okay.
Take care.
Bye.
Bye.